Hello, I welcome you all to this another interesting screencast, and the problem reads, the cables each exert a force of 400 newtons on the post. Determine the magnitude of the projected component of F1 along the line of action of F2. And the follow-up question is to determine the angle theta between the two cables attached to the post. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. So we have a pole, and the pole is subjected to some forces by using some cables. We have F1, we have F2. So we are being asked to determine the component of F1, a projected component of F1 onto F2. Alright, and then to determine the angle between F1 and F2. So in the first case, we are going to, for A, the first thing is we need to convert force 1 and force 2 into a force vector. So convert F1 and F2 into force vectors. Okay, that we're going to call F1 and F2, like so. And then the second step, once we've done this, then we need to find a unit vector. We need to determine a unit vector we are going to call unit vector 2 along the direction of force vector 2. Then once we've done so, since we have been asked to find the component of F1 onto F2, it's like we are projecting F1 onto the axis where F2 is. Okay, that's what we are basically doing, right? So it's like we are projecting F1 onto the axis where F2 is, and for us to do that, we first find the unit vector along the direction of F2, and then we dot the two vectors. So which vectors are those? Vector 1, force vector 1 dot the unit vector 2 along the direction of force 2, vector force 2. And then what we get is going to be the answer. And if this answer is positive, it means that vector is in the same direction with F2. If it's negative, it means it is parallel or along the same axis but in the opposite direction. Okay, is that fine? So we said if it is positive, then it is in the same direction. Okay, and if it is negative, let me show this. If it is positive, it means it is in the same direction like that. And if it is positive, and if it is negative, it means it still remains in the same, it will still remain collinear, but it's to be pointing in the opposite direction. Okay, this is negative. This is when it is negative, this is when it is positive for the answers that we are going to find. So we just have to change direction. So if you find it negative, then it is in green. If you find it positive, then it is in the direction of red. Okay, that is important. Then the second part, B, we have been asked to find the angle between the two vectors, and we know that we can express two vectors when they dot. Like in this case, we have force vector 1 dot unit vector 2. We know that this is equal to the magnitude of force vector 1 times the magnitude of unit vector 2 cos theta. So we are able to find theta by just making theta subject to a formula. Okay, and we have the following expression. Okay, So this is basically what we are going to do for this particular problem. Okay, let's dive into the problem and start doing the work. Said we need to convert f1 into a force vector, so let's do so. So we can write f1 as equal to fxi plus fyj plus fzk. Okay, so then what we need to do is, when you look at this force vector 1, okay, we are going to map a vector along the xy plane that we are going to call f prime. So let me put it in red, this one there, like this. Is that fine? So we map this, then let's call this as our f prime. Okay, and this f prime is equal to f, which is 400 itself, sine 35. So basically what we are doing is we are mapping it there like that. Okay, is that fine? We are mapping it there just using simple trigonometry. And then once we've done the mapping, then we'll need to map f prime onto the x-axis as well as onto the y-axis. And when we do so, then we are going to have both components in the x and in the y. Okay, is that fine? So fx, okay, which is this component, let me just draw them. So we're going to have a component there. How come I'm not able to draw this? I'm not sure why. Okay, anyways, so imagine those are the components there. So we have fx, then we have fy. So these are the ones that we are representing there. So fx is equal to f prime cos 20, right? Because we are mapping f prime onto the x-axis like that. Okay, is that fine? And therefore this is going to be equal to, if we were to write this to finish it off, it will give us a 400 sine 35 and then cos 20. Is that fine? 20 degrees. Okay, and then fy is also going to be equal to f prime sine 20, and this is going to be equal to 400 sine 35 sine 20, and then fz is equal to 400 cos 35 degrees. Okay, and then we have, now finally we find this force vector f1. This force vector f1 is going to be equal to, fxi. So fx is just 400 sine 35 cos 20 I. Okay, and then mind you have to mind the direction, I mean the sign. Fx is negative, so it's in that direction. Okay, is that fine? It's negative, I mean it's positive rather, it's in the positive x-axis. And then for y it is negative, so it will be minus 400 sine 35 then sine 20. Okay, and then the z-axis, I mean the z component, is positive. It is just 400 cos 35. Okay, sorry, this one is j, sorry, this one is in the x-axis, j plus k. All right, so that is the components or force vector f1. So we just need to simplify it now. So f1 therefore is going to be equal to, f1 will be equal to, if we did the multiplication, then we'll have the following values is equal to 215.59i, okay, minus 78.47j, okay, plus 327.66k. Okay, so we are done with the first part, which is just converting. We are still on A. We are just converting f1 into a force vector. So let's do the same for f2. We convert it to a force vector. So f2, the reason we are converting that is we want to use the same information to get a unit vector along the direction of force vector 2. So force vector 2, we can work it out. Since we have these angles, so we have an angle there, we have, let's say, an angle with the x-axis, let's call it alpha, is equal to 45 degrees, and then an angle with the y-axis is 60 degrees, and then the angle with the z-axis is 120. So these are the angles we want to use, and just use trigonometry, okay, or directional cosines. Okay, so 400, then we are going to multiply by these particular angles so that we get components in the respective direction, which is the x, y, and z. So in the x-axis, we said is 45, so we are just going to say cos 45i plus cos 60 degrees j plus cos 120k. Okay, so if we did the multiplication, then we will have converted this particular magnitude, force magnitude, into a force vector. So if we did the multiplication, we'll have a 282.84i, and then we'll have a plus 200j, and then we'll have a minus 200k. So we found both f1 and f2. So we'll go further now to find the unit vector along f2, direction f2. So say unit vector 2 is going to be equal to the force vector divided by force vector 2 divided by its magnitude. Okay, and we know that the force vector 2, its magnitude is already given and is equal to 400 newtons. This one here, you've seen this one, this is the magnitude. Okay, this is the magnitude of f2. All right, so since we have that already, so let's just feed all the information in our equation. So f2 is equal to, u2 or unit vector 2 is equal to f2 on top, force vector f2 is 282.84 I plus 200j minus 200k. Then each one we are dividing by its magnitude. Okay, so this is the unit vector, and we know to say the magnitude of a unit vector is always what? 1. Great. So now, having done that, what did we say? We said we need to dot the two vectors. What are we dotting? We are dotting a force vector 1 and the unit vector 2. Why are we doing so? Because we want to get a component of force vector 1 or a magnitude of force 1 onto the direction of force 2. Okay, so if we want to do that, then we need to make 1 the unit vector, and then where we need to get the component, we just leave it the way it is as a force vector. All right, so this is what we want to do. So we'll say force vector 1 dot unit vector 2 is equal to, so we dot the 2 now. We put the information in there. What is the force vector 1, it is 215.59I minus 78.47 J plus 327.66K. It's consumed so much in space, right? Okay, we move it like so. Then dot. There we go. I put a dot. Then I come back here. I come and put another vector. We are dotting, mind you. Unit vector. What did we say our unit vector is? Our unit vector is 282.84 divided by 400 I plus 200 divided by 400. If you want, you can simplify this further. Okay, 200 divided by 400K. So there we have two sets of information that we are dotting. And if we dot the two, we know what we are supposed to do that. Okay, we multiply this by this plus that by that. So that by that, that by that, and then finally this by this, right? Remember that, right? Great. So when you do that, then you are going to find that your f1, force vector f1 dot unit vector 2 is going to be equal to minus 50.62 newtons. So what does the minus say? The minus says instead of having the magnitude facing in the direction of the unit vector, it is facing in the opposite direction. Okay, so let me draw where this is facing so that you see it there. Okay, it is in that direction like that. It is still along the same direction with f2. The only thing is just the opposite direction. Okay, is that fine? Great. So there we go. This is it. The only thing, that is what it means when you have a negative like that. So this is the 50.62 newtons. This is the component magnitude of the projected component of f1 along f2. It is along, is collinear with f2, but just in the opposite direction. Right? So we found the first part. Okay, so we are doing part A all this time. So let's go to part B. Okay, what is part B? We determine the angle between the two, force vector 1 and force vector 2. The problem has even become more simpler because we know that f1, okay, dot, when you dot two product, you can also express them like I said earlier on during the introduction. You can also express them as a product of its magnitudes times cos the angle between them. Okay, so this I did mention during. Okay, and therefore, and we know from this information that f1, the magnitude of f1 is already there given in the problem. Is what? Here. What's the magnitude? 400. You don't have to calculate anything. It's given already. You just have to pick it. Okay, it is 400. And then we also know to say the unit vector. What is the magnitude of the unit vector? We've always known that the magnitude of the unit vector is what? Is 1. Great. So we have everything, and we also have this information f1 dot f1 vector dot unit vector 2 is equal to minus 50.62. So all we do is just make theta subject to the formula, which is cos inverse of force vector 1 dot unit vector 2 divided by their magnitudes. Okay, Alright, and therefore this is going to be equal to a minus 50.62 divided by 400 times 1, and theta therefore is going to be equal to 97.27 degrees. Alright, so let's write down the summary. Let's write down the summary of the solution, the final solution, which we've already found. We're just writing the summary. Therefore, F1, a component, what did I say? Component, a component of F1 projected component of F1 along line of action of F2 is equal to a 50 point a 50 point a 50.62 newtons, and the angle between the two vectors is equal to 97.27 degrees. This is about it, and I hope the video was helpful. If it was, give me a thumbs up, continue subscribing and liking my channel, as well as sharing it. Bye bye, and see you in my next screencast.